Welcome to Ask and Learn.
If this is convergent, then the ratio test is going to be able to give us some information. If the ratio test is conclusive, then this would be strictly less than 1. If this is convergent, but the ratio test is inconclusive, then we would be equal to 1. So this is all we can say, is that this is less than or equal to 1. So limit as n goes to infinity of absolute value of Cn plus 1 over Cn is less than or equal to 1/4. Because 4 to the n plus 1 divided by 4n is 4. So if we divide both sides by 4, then we get this inequality here. So now we can use the ratio test in part A. Okay, and with the absolute value signs, we can forget about this minus sign here. So we can just treat it just like a regular 2. As we saw, c to the n plus 1 over cn is less than or equal to 1/4 in absolute value. 2 to the n plus 1 over 2n is 2. So this is just 1/2, which is less than 1. So that is convergent. Okay, and then for part B, we can't conclude convergence. Okay, so that's what the problem is asking. Can we conclude convergence in the following series? So for part B, we cannot conclude convergence. So we can just use a counterexample here. So if Cn is minus 1 to the n over n times 4 to the n. So if this is what Cn is equal to, if we plug that in here, then we would get sum from n equals 0 to infinity. So maybe we should put a n plus 1 here instead of an n. So if this is what we have, then sum from n equals 0 to infinity of Cn times 4 to the n, that's going to be minus 1 to the n over n plus 1. So this is going to converge, but notice that if we have our Cn times minus 4 to the n, then we would wind up with this sum, which does not converge. So we can construct a Cn such that this converges, but this does not converge.